Okay, so just to link these two videos together, this is a continuation of our very first single variable stats topic, okay, which is frequency diagrams, nature of variables, grouping data, starting to look at single variable statistics, okay, and the bar graphs and polygons, and choosing effective graphs to go along with our single variable stats. So it's a long lesson, so I'm probably going to be breaking the video up into maybe three parts. I don't know, I haven't decided yet, okay. We'll see how long it goes and see if I get a bit tired, but either way, what we finished time looking at was the different types of frequency: relative, cumulative, and raw frequency. We looked at the different types of diagrams that we can use, and we also talked about the nature of data: categorical, discrete, and continuous. So moving onwards, we're going to talk about data in a process that we actually do a lot more often, and should do a lot more often than you'd think. And it's seen a little bit more with continuous data rather than discrete data. But anyway, that's neither here nor there. Okay, so first of all, it's the topic to start with is grouping data. Okay, now if you looked at our last graph and our last bit of data, let me grab it. It's very doodly here. But if you look at our last bit of data, this bar graph seemed to make sense. Okay, there were only 6 outcomes, 6 values that were there. We had a frequency in all of them, and all of them were useful and helpful. And it showed a nice sort of balanced graph where we can measure the values and the outcomes compared to each other very nicely and easily when we look at them. No matter whether we had the raw frequency or the relative frequency, we could see the most frequent is the outcome of 3, and the least frequent is the outcome of 4 and 5, and so on. Okay, so we saw a nice distribution. But if you looked at, for example, this one, this is marks for a data management class. Now we'll decide in a second whether or not this is going to be discrete or continuous. We don't look at the numbers to decide whether it's discrete or continuous. Okay, these are final marks. If these are final marks, what you have to ask yourself is the only mark that you can get a 65 or a 64 or a 63. If these are marks for a data management class, for a final mark, there are so many assessments. You're going to have 8 unit assignments. You're going to have quizzes, tests, depending on whatever it is, the discipline that you're taking. When we look at overall grades, most people think that they're discrete because they're narrowed down to a 65, 66, 67, but no. Okay, you have to look at not what the numbers are, but what the nature of the variable actually is. Even if you look at a mark book printout that your teacher gives you, it's rounded to the nearest whole number. And you know that it's rounded to the nearest whole number because if you put one little assignment in, sometimes it goes up a percent even though it was roughly the same. Okay, so the whole point is it's rounded. As a result of it being rounded, what you're looking at is an approximation of the mark. And what you actually don't realize is, as soon as you start entering in some percentages and weighting them with different factors and so on and so forth, that an overall mark is not discrete. It's continuous, because all values are possible between 0 and 100%. Okay? So any value is possible within that range. So therefore, this is considered to be continuous. Some may debate it, but it's not debatable. Okay, now you may say to yourself, okay, if this was a multiple choice test out of 100, then this would be discrete. And the reason why it would be discrete is because you can get 55 of them right, or you can get 56 of them right, or 57 of them right. You can't get 55.3 or 56.7 of them right. Okay, but that's different. This is an overall mark. Okay, and because it's an overall mark, realistically, unless your teacher made every quiz or test out of 100, okay, and then made every weight factor nice and even all the way across, and you lucked out, it could be discrete, but in general, it should basically be viewed as continuous because all values are allowed within a spectrum. Try to think of it as that shading of that spectrum. Anyway, so this is going to be considered continuous. That's an important first step for us to look at things, and it's going to be an important feature. But what we're going to focus on right now is grouping our data. And there's a reason why we have to group our data. If we were to take this and we were to graph this, what you'll find out is this data is not very repetitive. So the lowest value, I believe, is 44, I think. Okay, so if we put on a scale 44, and then I think the highest is 95, I'm not sure. I think 95. Anyway, we're just doing a survey now. Okay, and we put one for 44, and we put the scale here at, I don't know, 1, 2, 3. We would get a bar at 44. Now at 45, 46, 47, 48, 49, I don't think I see any of the 40s. I'm getting old here, I may miss it. No, I don't see any of the 40s. So we wouldn't see another bar until we got to 51, I think. And then 55, and then 59. So we'd have a bar at 51, right? And we had a bar at 55, and then at 59, and obviously this scale is horrible. But the point is you're going to see there's all kinds of spaces in the graph here that don't make any sense, and we're losing all of this space. We're going to have this super long graph with, I don't know, from 44 to 95 entries. What's that going to be? 51 entries, 51 bars? What's the point? You might as well just look at the numbers. There's no point to a graph. And that's when we find when we have data that's not very repetitive, it's a good idea to group it. So we group it into groupings. And the natural groupings that teachers group these things into, as well as students, are 50s, 60s, 70s, 80s, 90s, 100s, or 90s to 100, right? And so those are the groupings that we find things in. Okay, but there actually is in your textbook a little formula that you can use to figure out the number of groupings. But I usually say to yourself, break it down to what's reasonable or what's useful. For us as teachers, it's going to be, 0 to 10, 0 to 9.9999, 10 to 19.999, and so on. So we put them in 10% categories or 10% groupings, and that's arbitrary. And you can only have a maximum of 10 out of 100%, and so it kind of sees where everybody falls. But the problem is when we do this is we lose resolution, because if we put a 10% in the same category as a 19%, there's a big difference. There's 9% difference between those two values. So you lose information. It's a summarization, but at least it allows you to make an accurate representation of what the class overall looks like. Okay, it's not as 100% accurate as it is, graphing all values, but it's a little bit of an approximation. And that's what a statistic is. It's a summarization, right? And so we do lose information, but we also gain an overall pattern. And so that's the process that we use. Okay, so first of all, I want you to act to simplify your groups so that there are no more than 20 and no less than 5. This is what the book puts in. And it's true. If you see more than 20 bars, you just forget about it and your eyes glaze over. And if you see less than 5, sometimes you're losing too much information because you're making your groups too big. Think about it. If I put all the people from 80 to 100 in one grouping and 60 to 80 in one grouping, there could be a person with a 60 and a 79 in the same grouping, but they're very different levels of performance in a course. So again, we lose information if we make my groupings too big. So you want to find a happy medium. Now, what they tell you is they get you to figure out in the book, they get you to figure out your range. So in this case, it would be, 96, I guess, was my highest, not 95. I must have missed it in here somewhere. I'm just glazing over it. There it is, 96. 96 minus 44. Okay, that would be my range. Okay, and then 52% is the range from the lowest to the highest mark. And then you divide it by your number of groups that you want. Okay, which doesn't seem to make much sense. I want 10 bars. I want 10 groups. Okay, so you divide it into 10 groups. So then you take your 52 and you divide it by 10 and you get 5.2. That means your group should be 5.2 wide. Okay, of course, it doesn't make any sense to make it 5.2 wide, so what will most people pick? They'll pick 5. So that's exactly what I did here. I want 10 groupings, so my group range is 5.2, so you'll probably make your range 5. That mean you have 11 rather than 10, or 9 rather than 10. But at least you're going to have sort of a nominal number of bars you think is appropriate. Or you can make it 5, in which case your groupings are going to be by 10%. Okay? But this is just a gauge for you to look. There's no hard and fast way to do it. In Microsoft Excel, it does do it this way. Okay, it does, when it creates its own distribution for you. And you can get it to create a distribution for you if you want to. Also, people tend to pick logical size groupings, 5s, 10s, 2s, that sort of thing, and not pick groupings of 5.5 or 2.3 or whatever. But it's up to you. You're welcome to do that if you want to. It just makes things easier. And of course, you also have to remember that other people are going to be reading this information and taking some information from it. If they're going to be reading and taking some information from it, then you really should make sure that it's understandable to the audience as well as just to you. Okay, also, so group ranges, again, you don't want to have too many groups, too few groups. Okay? You don't need to have too many or too few. You want to pick a group range size. You can calculate them if you want to. The third feature, and this is probably the most important feature, is that you have to make sure that all of your data values have a home and only one home. So that each measurement that you have can fall into only one category. So frequency can happen twice, because then what happens is, let's say you did 20 to 30 and 30 to 40 and 40 to 50. The number 30 can fall in the 20 to 30 category, and the number 30 can fall between the 30 and the 40 category. That means one value is going to have a frequency of 2. You can't have that. So you have to make sure all of your data values fall upon a specific value. Now, for discrete values, that works out fine. You just have to be careful about it. So instead of going 40 to 50, 50 to 60, 60 to 70, 70 to 80, 80 to 90, 90 to 100 for my data values, for my percentages, what I do is I say everybody's got a home, so I go from 40 to 49. And then I go from 50 to 59 and 60 to 69. Notice that even the number 50, the number 60 doesn't go into two groupings. If I went 50 to 60, it would go into this grouping and it would also go into this grouping. Okay, now you may say to yourself, okay, 40 to 49, 50 to 59, 60 to 69, 70 to 79, 80 to 89, 90. And for our data, that's perfectly fine. You look at our data, no problems. No problems. Each one of these is going to have a home because they've been rounded. For discrete data, works beautifully. This is beautiful for discrete data. And it may also work for our continuous data. So these percentages are continuous. It may work for us, but we can't do that for continuous data because continuous data has no spaces. And if you'll notice, there's a space between 49 and 50 where it's not included, and a space between 59 and 60 and 69 and 70. If it's continuous, you cannot, continuous data cannot allow spaces between the data by definition. It has to be a spectrum because we graph it a little bit differently. If it's discrete, no problem. This is it, move on, your world is a beautiful place. But if it's continuous, we can't have spaces. So what do? We modify it slightly. So we don't go from 40 to 49 and 50 to 59 because there's between 49 and 50 that's missing. Okay? So what we do is we say, okay, well, I'm going to go for 40. I'm just going to make it 39.5. And then it's going to go up by 10 to 49.5. Now, in essence, what I'm including is from 39.5 to 49.5, or really from 40 to 49. I'm doing the same thing that I'm doing there. But notice that when I go from 39.5 to 49.5, my next grouping begins with the 49.5. So there's no spaces between my groupings. You can't have spaces between your groupings for continuous data. So this is how you do it. So it goes from 39.5 to 49.5, 49.5 to 59.5, 59.5 to 69.5. So you notice that there's no spacing between the groupings. And you say, well, but Mr. Henley, that doesn't work because what about 59.5? What if you have a measurement of 59.5? Where does it go? It's going to go in this grouping and it's going to go in this grouping. Absolutely. So what do you do then? You don't go 59.5, you go 59.55 and 49.55 and 39.55 and 49.55. You adjust the groupings in the intervals so that there's no spaces between the intervals for continuous data. Discrete, it doesn't matter, but for continuous, it matters. No spaces between the variables for continuous data, and everybody has a home. Okay? So even if a 49.5 comes up, 49.5 goes into this grouping right here because this goes all the way up to 49.55. And 49.55, that would be where 49.6 or 49.7 or anything above that will go into. Okay? Now, because this is continuous, I have to create, for my data set, I have to create a grouping for that data set that's going to be appropriate. Okay? So it's continuous data, so what do? So I say, okay, I'm going to go from 39.5 to 49.5, 49.5, 59.5, and so on. Then what I do is I go back and I check my data. I'm going to have to use a different source for my data. So I go back and I check my data. And I say to myself, okay, do those groupings work? All right, well, all of these are whole number values, so that means that everybody's going to have a home. Oh, one last thing I forgot to tell you guys. Don't forget, all of your intervals, all of your groups, they should be the same size. Notice that all these groups are 10, 10, 10, 10, 10, 10. 10, 10, 10, 10, 10, 10. Make sure that all your groupings are exactly the same size. Okay, that's another thing that we have to make sure that we do. Okay, as well as making sure that they fit into it properly. Sorry, a little bit of a sidetrack. Anyway, so what we want to do is we want to be able to fit all these values. So if we take any particular one of these and we're like, oh, you know, there's a 50, let's say there's a 55.5. I'd be like, oh, that's a problem. I can't use this. Or sorry, let me find another one. 59, was a 9. 96. Oh, 89. So let's say that was an 89.5. That one would be a problem for us if there was an 89.5. If my data had an 89.5 in it, then I would have to make this an 89.55, and all of my categories would have to have 5 5s on them. Okay? And that would make sure that my 89.5 would actually be in a specific grouping. Hopefully you understand this idea. It's a little bit of a fine-tune more than anything else. It's a bit nitpicky, but I wanted to make sure you had all the information that's out there. So what I'm going to do is I'm going to group this data. Okay? Now, I'm just going to kind of lift this up here and use this piece of paper here. Okay, here's my data down here, and I'm going to create a tally chart. Okay, and when I create this tally chart, you don't have to do tally chart. You can go straight to frequency if you want to by counting them up as you go, but people tend to miss things. And if they tend to miss things, you don't want to be in that situation. It's not a good thing because you're like, oh, well, we should have 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. We should have 32 values and we've missed some. Okay, and sometimes I even do this myself when I do it quickly on videos or in front of classes and stuff. So I always get my students to do the same tally too. So maybe you should do the same thing as well. So we're going to group all these into groupings. Now remember, this is kind of like my 40s, 50s, 60s, 70s, 80s, 90s. Okay, so it's an easier way for you to visualize what that's going to be when you go through it. So this is a 78, so it goes in my 70s. And usually it's a good idea to sort of lop them off. So an 81 goes in my 80s, a 55 goes in my 50s, a 60 goes into my 60s. I know it's barely in there, but it is. 65 in my 60s, 86 in my 80s, 44 in my 40s, 90 in my 90s, 77 in my 70s, and so on. And I will continue on with that tally. I'm not going to continue it on with you. I'm going to cheat. Okay, and I'm going to use a tally chart that's already been developed for you. But you can, if you want to press pause here and go through and do your own little tally chart, great idea. It's good for you to go through this process yourself so you know. But you end up having 140, okay, 4 that are in the 50s, 7 that are in the 60s, 11 that are in the 70s, 6 that are in the 80s, and 3 that are in the 90s. You add them all up, that's 5, 12, 30, 23, 29, 32, and you're like, oh, do I have 32 data points? Yes, I do. And it's always a good idea to do a sum for these things. Very useful. Most people don't do sums for the tallies. Okay. You'll also notice I have a stat in here called the midpoint. The midpoint is going to be important for when we do later on statistics, looking at measures of potential tendency, and often we can even graph using the midpoint as well. Okay, so from there, of course, we'd want to do a relative frequency. A relative frequency is going to be 1 divided by 32, or a 4 divided by 32, or a 7 divided by 32, or an 11 divided by 32, or a 6 divided by 32, or a 3 divided by 32. Again, it can be communicated generally as a percent or as a decimal. In this case, I'm going to have to do some rounding. So this is 0.03, dot, dot, dot. This is 0.125. This is 0.21875. This is 0.34375. This is 0.1875, and this is 0.09375. Okay, and those are just simple arithmetic division questions. If you want to get a calculator, go ahead and do that yourself. That's a good idea. This is just a dot, dot, dot. For here, this should add up to 1. Or if you express it as a percentage, it should add up to 100%. Okay, it may add up to 99.9% because you rounded, but to more or less get there. Okay, and if you keep all the decimal places, it should add up exactly to 1. For the cumulative frequency, I'm going to do this one to you because sometimes people do this one with you because sometimes people get a bit weirded out by this one. So for this grouping, for the 40s, my cumulative frequency would be 1. Because I'm looking at the amount of individuals who got, or the amount of marks that are 40 or below. Well, there's only one mark that's 40 or below. Here, I want to look at the amount of marks that are 50s or below. So there's 4 50s. Don't look at the tallies, remember, because I never finished it, but look at the frequencies. There's 4 50s, but the cumulative frequency is not 4. Then it would be the same thing as the frequency. It's going to be 4 plus the 1, okay, or a running total. So I've got 4 50s plus 1 40, so that's going to be a 5. For the 60s, it's going to be any marks that are in the 60s or below. Okay, so it's going to include the 60s, which is 7, and then the 4 for the 50s, and then also the 40s. So this adds up to 12. Okay, and then for this one, it's going to be the 70s and the 60s and the 50s and the 40s. So it's going to be the 11 and the 7 and the 4 and the 1. That's going to be 11 of 22, 23. And then the 80s is going to be 80s, 70s, 60s, 50s, 40s. Okay, so it's going to be, it's going to be 29 of them. Okay, and then finally, the very last category is going to be the highest mark or highest mark grouping, and that's of course going to have that value and everything below, which means it's going to have everything. So this last entry and the total frequency is always going to be the same. We don't generally tend to do a running total for this, so I put NA for not applicable or not useful for us in that perspective. And then from that, what we will want to do is we will want to graph that. Okay, so that's what I'm going to do. I'm going to quick graph. Okay, it's going to be ugly, but it's going to work. So let me get some scrap paper here. Okay, we're going to graph this data, so I'll leave it available for me right here. Okay, obviously I'm going to want to make sure that I do a nicer job with this, but this is just sketch, so you'd want to use grid paper or the computer, whatever it may be. My highest frequency is 11, so I'll go 2, 4, 6, 8, 10, 12. Okay, and this, of course, is going to be, we're going to do frequency, or raw frequency, if you want to call it that. In which case, this is going to be a raw frequency distribution. Those of you who are looking at this video and saying it's a really ugly graph, on your notes, you have a nice, beautiful graph. Let me show you what it looks like. Final analysis. Now, it's not beautiful. Beautiful, I still did it by hand, but it's a bit more authentic and it talks to you a bit more and it gives you a nice title and so on and so forth. So make sure you have a look at that. But either way, and you have all your outcomes here. Now, remember, this is a continuous outcome, so you want to put on a scale. The scale here, most people are probably going to, you really should put a 39.5. But again, most people kind of tend to put an approximation in there. So they may go 40, excuse me, 50, 60, 70, 80, 90, and then finally 100. Okay, that's my random variable x. And I always define the x, so these are percent grades in data management. Okay, and then of course, what do? I do the bars. Now, this is continuous data. For continuous data, it's a spectrum. If you remember for discrete, when we saw the graphs, they had spaces between the bars. These one won't have spaces between the bars. So this diagram is actually a histogram. Not a bar graph, but a histogram. I'll go over the differences between the two. But when I draw them, the bars are all scooched next to each other. And the reason why is there's no spaces between the numbers. And as a result, we don't graph it with spaces between the numbers. So if I look at the frequency for the 40s, it goes up to 1. So it's this little tiny little 1 here, this little bar here. And I draw it like that. You can shade it in if you want to, or make a color. You get your pencil crayons out if you want to, whatever you want to do. Okay? Here there's 4 for the 50s. So I want to go up to 4. And I want to shade that one in too. Maybe a different color, whatever you want. Okay? For this, notice that there's no spaces between these two bars here. No space between the two bars because this is continuous data. And I'll finish off the title in a second. Okay? And then from there, my next is a 7. So I go up to 7. And again, I'm just eyeballing this. So for those of you who are looking on top of this, I'm looking at it from the side view, so it may be a little ugly. Okay, and there's your 7. Finally, the 11 for the 70s to 80s. 11, halfway between the 10 and the 12. Okay, put that in. And then we've got a 6 and a 3. So 6 straight across here. And then a 3 goes like that. Okay. Now, one thing that's important, although I haven't done a very good job with it, is that all these bars should be the same size and all these intervals should be the same size. Okay. And then the heights, of course, are the only things that vary in size. You don't want to vary in width as well. That's inaccurate. You don't want to do that. Also, you want to, if you have a scale here that starts at 0, beautiful. But if you have a scale here that starts at 0, you need to put a break in the axes. Okay, so that we understand there's a whole lot of stuff that we don't need to include all the way down to 0. So we put a break in the axis when we start seeing measurements. Don't put breaks within axes, only without. Okay, on the either end of them. Okay, sometimes you can do that. It's not really very mathematically correct, but people do it. And so this is called a raw frequency distribution. Now, I don't just want to say raw frequency distribution, done. I want to say raw frequency distribution showing the percent grades of Mr. H's data management class. Let's say it's my semester I just finished. So we'll go winter 2020, maybe call it COVID-19 online class or something like that, whatever. It's got some information in there. It tells you a little bit more about it. I like nice descriptive titles. You leave a title out, you lose a mark. If your title's not descriptive, you're going to lose a mark. Okay, and there's some notes about that in your good copy version of your notes. It says things that I expect for you to have. Okay, the only other thing I want to include in here as well is you can also, instead of putting scales at either end, you could put the midpoint here of each interval. But the bars are still going to be together. Still going to be together. Okay, so there's how to do an effective graph, really ugly effective graph, but an effective graph in